Hey everyone, so previously we saw the properties of sine and cosine function, and if you remember, we looked at the domain, which is negative infinity to infinity. The range of the sine function is given by negative 1 to 1, right? So the domain is all real numbers are negative infinity to infinity. The range, as we saw, is always going to be negative 1 to 1 with the endpoints included, right? The sine can never take a function, a value over 1 or a value below negative 1. We also saw that the period of the sine function was 2 pi, right? That is, after every 2 pi, the values repeat. And then we also looked at it had no asymptotes, and at zeros were all multiples of pi, right? Where n is an integer. Okay. So what we're going to do today now is in this video, we're going to try and graph this function. So I'm going to do it by hand. I'm going to show you how the graph of sine x comes about. And then what I'm going to do is we're going to go ahead and pull over Desmos, and then I'm going to show you the exact graph of y equals sine x. All right. So let's look at the table, right? Here are a few values, basic values of sine function. And we know that sine of 0 is 0, pi over 6 is 1 over 2. Sine of pi over 4 is 1 over root 2, or as we saw the last time, it can also be written as square root 2 over 2. Same for sine 3 pi over 4, 1 over root 2 or square root 2 over 2, right? Now, notice that the values from 0 to pi over 2 are in quadrant 1, and the values of from pi over 2 to pi are in quadrant 2. And we know that in both these quadrants, sine is positive, right? And then obviously, if you go to quadrant 3 and quadrant 4, I'm going to get values of sine to be negative. Okay, so what we're going to do now is we're going to try and graph this, right? I'm going to start with the unit circle, and then I'm going to sort of translate that into an xy plane, get a graph going, and then we'll see later what the exact graph looks like using Desmos. Okay, so here's my unit circle. Okay, so let's say this is my x-axis, and that's my y-axis. This is my origin here. This is 1, 0, 0, 1, negative 1, 0, and then 0, negative 1, right? If you remember, sine was nothing but your y values, okay? So we know that sine of 0 is 0, so I'm going to go ahead and mark that using a red marker. So sine of 0 is 0, which is over here, okay? Then we have sine of pi over 6 is going to be 1/2, and so that's going to be roughly over here, and that's your value of sine, okay? So this is sine of pi over 6, which is 1/2 pi over 6, comma 1/2, okay? And then I have sine of pi over 4, which is root 2 over 2, so pi over 4 is going to be somewhere around here, about here. Okay, and so this is going to be pi over 4, and then this is going to be root 2 over 2 or 1 over root 2, whichever you prefer. Then we have pi over 3. Pi over 3 is going to give me root 3 over 2, and then pi over 3 would be somewhere around here, so that's about 60-degree angle. And so this is going to be pi over 3 and then root 3 over 2, okay? Finally, I have pi over 2 is 1, so that's my point there. So that is also my point, pi over 2, comma 1, okay? Continuing, I'm going to get this over here, which is 2 pi over 3, comma root 3 over 2, okay? And then I have 3 pi over 4, which is going to be about here. And then finally, 5 pi over 6 and pi. Okay, so this is 5 pi over 6 and then 1/2. And then this is going to be 3 pi over 4 and then root 2 over 2. Okay, so let's look at now what I'm going to do is we're going to translate this into our xy plane. So I'm just going to draw the first two quadrants, right? So I have my y-axis here, and I have my x-axis over here. Okay, so since I'm going, basically I'm going from 0 to pi, so I'm going to go 0 And then let's see, this is pi over 4, pi over 2, 3 pi over 4, and pi. Okay, so we know that sine of 0 is 0. Okay, so that's going to be sine of 0. Now, sine of pi over 6 is 1/2, right? So pi over 6 is going to be somewhere around here. Okay, and that's 1/2. So basically what I'm doing here is I'm translating this segment over here. So if this distance here, if I translate this distance, if this is 1, and let's say this here is -1, okay, so 1/2 would be about here in the middle, and so I'm literally just taking this segment and putting it in here, and so that's the height that my point is going to fall at, okay, and then I have root 2 over 2 at pi over 4, which is this segment over here, so it's going to go about this height here. Okay, then I have root 3 over 2. Root 3 over 2 is going to be about somewhere around here. And then finally, I have a value of 1 over here, another root 3 over 2, and this is going, so this one is pi over 6, this is pi over 3, this is 2 pi over 3, and then at 3 pi over 4, I have another root 2, so that's going to be out here. And then at pi over 6, I'm going to have another 1/2, right? So this is 1/2. This here is root 2 over 2. And then this here is root 3 over 2. Okay, so basically, and then again, I have here 0. So if you look at, if I join my points for my sine graph is going to look something like that. Right, and then it's going to go down and so on and so forth. So my sine function basically takes this wave shape, right? It goes this way all the way down, okay? And it continues. And this is going to come back up at 2 pi, right? Because that is 1. So this is one period of my sine function. And since sine has a period of 2 pi, basically just take the shape copied wrong, and you're going to get the entire graph of the sine function. So let's take a look at the computer and let's see what the exact graph of sine looks like. All right, so as we see here, what I've done is I have plotted the points. So basically I made a table of all the standard angles that we have from 0 to 2 pi, okay? And then I plotted the values of sine here. So if I go ahead and plot these values, this is what I get. If you remember, this is basically the shape up to here. This is your point pi, right? Pi 0. And this is your point 0, 0. And this is the shape that we graphed on the board, right? And so this is one complete cycle of your sine function. Now let's go ahead and activate the graph of sine. And if I do that, well, that's the graph of my sine function. So if you see, my sine function is in the form of a wave, right? So I'm just going to zoom out a little bit here. And so this keeps on going, right? It's a never-ending function. As I said, my domain is -∞ to infinity, so there are no breaks in this function. It's a smooth curve. And if you look at it closely, my range of my sine function, right, this point here, if you look at the y value is 1, and this point here, which is the lowest point, my y value is -1. So you can see that the range of my sine function is from -1 to 1, okay? Also note that from 0 to 2 pi, right, this is one period of my sine function, and essentially, if I just go ahead and copy the shape all the way through, I'm going to get the graph of sine x. So once again, I'm going to zoom out. This is your graph of y equals sine x.